Students, you're welcome back. We are still on the series of lessons on circuit theorem. So in this video, we look at theorem 4. We're looking at theorem 4 in this video. So theorem 4 says that opposite angles in a cyclic quadrilateral are to 180 degrees. Opposite angles in a cyclic quadrilateral are to 180 degrees. So that is what the theorem says. That you have a cyclic quadrilateral and then you add the opposite angles, you get 180 degrees. So what is a cyclic quadrilateral then? What is a cyclic quadrilateral? We have to know what a cyclic quadrilateral is. So a cyclic quadrilateral is a quadrilateral inscribed in a circle with all the four vertices touching the circumference of the circle. When you see a cyclic quadrilateral, no, a quadrilateral is a four-sided figure. So quadrilateral has four sides. So a cyclic quadrilateral is in a quadrilateral that is inscribed in a circle. But the one thing you have to know is that all the vertices, the four vertices must touch the circumference of the circle. So if the four vertices don't touch the circumference of the circle, it cannot be a cyclic quadrilateral. Okay? So for example, if you have this, let's say this one is a circle, and then we have this one here. This is a quadrilateral. We have this. This one is not what? It's not a cyclic quadrilateral. Why? Because this vertex is not touching the circumference. Yes. That is so in the same way, if you have, let's say you have a circle here, and then you have a quadrilateral like this. This is a quadrilateral, but it's not what? It's not a cyclic quadrilateral. Why? Because these two vertices do not touch the circumference. Okay? So it's a cyclic quadrilateral is a quadrilateral with all the four vertices touching what? The circumference of the circle. It's a quadrilateral. A cyclic quadrilateral is a quadrilateral inscribed in a circle with all the four vertices touching the circumference of the circle. So this is a cyclic quadrilateral. You see, this vertex is touching, this vertex is touching the circumference, this one is touching, this one is touching. This angle is B, angle A, angle D, and angle C. So which angle is opposite to D? You see that these two angles are opposite angles, and then these two angles are opposite angles. So what this theorem is saying that if we add these two opposite angles, we get what? 180 degrees. And if we add these two opposite angles, we get what? 180 degrees. What does it imply? It implies that A plus B will give us 180. That's why we have written that A plus B is what? Equal to 180 degrees. And B plus D, which are opposite, also give us what? 180 degrees. So this is what this theorem is. It's very simple, not difficult at all. So thank you for watching. Don't forget to subscribe to my channel and see you in the next video. Hello students, okay, welcome back. We are looking at example on theorem 4, that is a theorem on the cyclic quadrilateral, that the opposite angles in the cyclic quadrilateral are 180 degrees. So look at this. This is a circle, and then we have to know that this is a quadrilateral, cyclic quadrilateral. So this side of this chord extends to the outside of the circle. This side also goes to the outside of the circle. But there's another line here. There's another line joining. So this is the cyclic quadrilateral. This is one side, another side, and then you have another side, another side. So this point, this vertex is touching the circumference. This vertex is also touching the circumference, and then this vertex is also touching the circumference. This vertex is also touching what? The circumference. So by this one, we have a triangle going out from this side of the cyclic quadrilateral. Okay, so what do we know? The theorem states that opposite angles, when you add the opposite angles in the cyclic quadrilateral, you get 180 degrees. So it means that if you add x to y, you have to get 180 degrees. But let's just deduce something. Always this, you see that this angle here is always equal to this angle, and then this angle M is always equal to the external angle. Okay, fine. Because at times you can be given a question where by this line can be extended outside the circle like this. So that is why it's very important to look at this. So let's look at something. We know that x plus y is equal to what? 180 degrees. Why? X plus y. This is x and then plus y, because the opposite angles in this cyclic quadrilateral, when we add them according to the theorem, we have to get 180 degrees. Okay. So look, x plus y will give us 180. But when you look at this, when you are at this point, this is y. But this angle here is also what? This angle is 180 degrees because it's an angle on the straight line. It's 180. So it means that when we add y to t, y to t, we get 180. So y plus t will also give us what? 180 degrees. So this one, the first one is equation 1, this is equation 2. So let us subtract equation 2 from equation 1. So we see that equation 1 minus what? Equation 2. So we get x plus y, and then minus what? Y plus t is equal to what? 180 minus what? 180. 180 minus. So when we remove the bracket, we get s plus y minus s minus t is equal to 180 minus 180 is what? 0. So this y minus y will go away. Then we get s minus t is equal to 0, which implies that s is equal to what? S is equal to t. So you see, that's what I was saying. So this s is always equal to this external angle here. But when you add this to this, we get 180. It means that then you have to subtract this y from 180 to get this side, and then that one will give you this same t. Have you seen? In the same way, when you also have this, when you add m to n, you get what? 180. M plus n also give us what? 180. But since this is this also an angle what? On a straight line from here to here, when we add this angle, we also have to get what? This angle to this angle, we have to get 180, because this angle on the straight line. So this angle is n and this is r. So n plus r will also give us 180, equation 1 and equation 2. So in this way, we also subtract equation 2 from equation 1. So we get m plus n minus what? Minus n plus 1 r. So minus n minus r is equal to 180 minus 180, which is 0. So n minus n will be 0. So we get m minus r is equal to 0. And then r will go to that side, and then we have m is equal to r. So it means that this m is also equal to what? R. Very powerful. It's very, very powerful. You have to note. Very, very, very powerful. You have to note. Because this one is very, you can apply it in fact in a lot of questions. The question whereby this cyclic quadrilateral, the line is extended outside the circle is very important, so you can consider that. So thank you for watching. See you in the next video. Okay, viewers, we are still on theorem 4. So we are looking at these examples on theorem 4. So we are asked to find s and y in this diagrams. Okay, fine. So what do you see here? This is a circle, and this one is a quadrilateral inscribed in the circle, where all the 4 vertices are touching what? The circumference of the circle. So it means that this is what? A cyclic quadrilateral. And from the 4th theorem you just consider, you know that opposite angles in a cyclic quadrilateral are to 180 degrees. So it means that, so you say that since from here, from this side, you say since what? Since opposite angles in cyclic quadrilateral add to 180 degrees, it implies that x plus what? X plus 84. X plus 84 will give us what? 180. Have you seen? Okay, so x is opposite angle. So s, when we add s to 184, you have to get what? 180 degrees. That's what they, according to this theorem. So which means that, what does it imply? It implies that what? Sorry. It implies that x is equal to what? 180 minus what? Minus 84. What is 180 minus 84? Is what? 96. So which is 96 what? Degrees. It means that this angle is what? 96 degrees. Fine. Also, y and 102 are opposite angles in this cyclic quadrilateral. Also, when we add y to what? 102, you have to get what? 180 degrees. Why? Because they are opposite angles. Y and 102 are opposite angles in this cyclic quadrilateral. So what does it imply? It implies that y will be equal to what? 180 degrees minus what? Minus 102. So what is 180 minus 102? So this is what? 78 degrees. So it means that here x is equal to what? X is equal to 96 degrees, and y is equal to what? Y is equal to 78 degrees. Okay, so let's look at this example. Everything. So in this you have to find what? S and y. We are still finding s and y here. So we know that we know that this S and 64 are hot opposite angles in the cyclic quadrilateral. So when we add them, we have to get on 180. Know that S plus what? 64 will give us what? 180. So S is equal to 180. 180. S is equal to 180. Okay, so S is equal to 180 minus what? 180 minus 64, which is equal to what? Equal to 160. Sorry, 100 what? 160 what degrees. So it means that here S is equal to what? 116 degrees. Okay, fine. We are supposed to find Y here. So how do we find Y? This is 55. Therefore, as we saw from the previous illustration, Y is equal to 55. Y is supposed to be equal to 55. Why? Okay, so let's say we don't know. So if we don't know, we can find this angle. So let's assume that this angle is what? This angle is T. So this is a cyclic quadrilateral. Therefore, the opposite angles in the cyclic quadrilateral will give us what? 180 degrees. So it means that T, if you add T to 55, it implies that T plus what? T plus 55 will have to give us what? 180 what? 180 degrees. Okay? So T will be equal to what? 180. 180 minus what? Minus 55. What is 180 minus 55? This is 125. 125 degrees. So it means that T is equal to 125 what? T is equal to 125 degrees. So we know T. But from here to here, from this T, this angle T mark, the whole angle here is 180. So if you know that if we add this Y to T, you get what? You get 180. But what? T plus what? Y is equal to what? 180 degrees. Angles on the straight line. So what does it imply? We are looking for Y. So Y is equal to what? 180 minus what? Minus T. So Y is equal to 180 minus what is T? T is equal to what? 125. 125. So which is equal to what? 55. So we come back to 55. So Y is equal to what? 55. So that was why I was saying that Y is equal to what? 55 degrees. So if you know this very well, when you are solving a question, you don't worry. Getting question, you don't have to worry yourself. Just know straight away, and then you just get your answer. So you see, it's very simple. Very simple. In the next video, consider theorem 5, and then look at. I mean, we are considering these examples, but after looking at this lesson fully, after we have finished with this second theorem lesson, we look at what examples, some more examples. That one will help you clarify every doubt, everything for you. Thank you for watching. Don't forget to subscribe. Don't get confused. Get understanding. Don't memorize. Because if you memorize, you get confused. So don't forget to subscribe to my channel. See you in the next video. Thank you.